Okay, now we are going to discuss a moving coil galvanometer. Okay, it's a video. हा व्हिडिओ कोणासाठी आहे जो absent for regular lecture. So, moving coil galvanometer is a device for measurement of small current. On which principle it works? As principle of moving coil galvanometer. So, as moving coil galvanometer works on principle that when current carrying coil that we discussed in previous lecture place in magnetic field, as that coil experience a torque means coil rotate होते ज्या कॉइल मधून ज्यावेळी करंट फ्लो होतोय त्यावेळी कॉइल रोटेट होते. Okay, by acting a couple, this torque cause coil to rotate and amount of rotation means deflection is proportional to current flowing through the coil is a working principle of this moving coil galvanometer. So in moving coil galvanometer, okay, a radial magnetic field is used. A straight magnetic field, the north and south pole, okay, will use a radial magnetic field, okay, in which this rotating coil is kept or suspended using this phosphor bronze string suspended in this magnetic field and supported by a spring. म्हणजे ही जे रेक्टँग्युलर आहे हा रेक्टँग्युलर दिस रेक्टँगल नथिंग बट एस कॉईल ही कॉईल आहे हॅव्हिंग एन नंबर ऑफ टर्न्स आणि ही कॉईल ह्या मॅग्नेटिक फील्ड मध्ये ठेवले. And magnetic field is a radial magnetic field. Purposefully, it is a radial magnetic field to get a uniform torque. This coil is suspended by phosphorus bronze through which current flows. Mirror for recording reading. Okay. So, as current when flows through this coil, may current come from top from this phosphorus bronze and flows through this coil. Now we have condition what? Is this coil which is wound on soft iron, okay, through which when current flows, as we get a condition that current carrying coil are kept in a magnetic field. Then it acted upon by torque. How much torque it acts is for that derivation we derived. A torque is number of turns of the coil. As number of turns of the coil, current I, area of the coil, magnetic field and angle theta we say. And now very important, why radial magnetic field? As theta is angle between normal to the plane of coil and magnetic field direction. If radial magnetic field typically used in moving coil galvanometer, magnetic field lines are perpendicular to plane of the coil. Thus, for any orientation, means it rotates through any angle. Thus, at that time, magnetic field is perpendicular to what plane of the orientation. And we get that theta as 90 sine theta 1 and therefore uniform torque every time act on the coil. म्हणजे याचा अर्थ काय की रेडियल मॅग्नेटिक फील्ड मुळे ह्या कॉइलवर टॉर्क ऍक्ट होतोय अँड टॉर्क हाऊ मच कॉन्स्टंट टॉर्क एन आय ए बी ऍक्ट ऑन दॅट कॉइल. आता ह्या टॉर्क मुळे काय होतं की कॉइल रोटेट होते इन मॅग्नेटिक फील्ड. दिस कॉइल रोटेट इन मॅग्नेटिक फील्ड. मग ह्या रोटेशनमुळे स्प्रिंग गेट ट्विस्ट आणि ह्या स्प्रिंग मध्ये रिस्टोरिंग टॉर्क डेव्हलप होतो किती के थीटा के फाय किंवा के थीटा म्हणतो आपण थीटा ऑलरेडी यूज केलंय त्यामुळे ऍज पर आवर नोट्स गिवन इन बुक वी से के फाय दिस मच टॉर्क डेव्हलप. ओके सो हाऊ मच डिपेंडिंग अपॉन करंट इज दॅट कॉइल रोटेट बाय दिस टॉर्क a same amount of torque develop in that spring. So this, for reading for that moving coil galvanometer, restoring torque is equal to deflection torque. Restoring torque how much? K pi, a torsional constant K, into NIAB, and from that we have deflection is NAB by K constant proportional to current, number of turns, area B, and K constant. And therefore, as for moving coil galvanometer, deflection is a directly proportional to what? Current. Is it clear? So what you ought to remember for this, when current flows through coil of a moving coil galvanometer, it will rotate by a torque, and due to this rotation of torque, restoring torque develop in this lower suspended spring. Lower suspended spring. Thus that balance that torque, and by which we get expression for deflection of this moving coil galvanometer. So hope so you understood this. हे कळालं असेल. नाही कळालं असेल तर मला रेग्युलर क्लासमध्ये यायचं. You have to ask a doubt. So important formula phi NAB by KI. Is it clear? Thank you.